How long will our HEPA filters last under normal production? Until now, the honest answer was, it depends. It depends on many things: airborne particulate concentration and composition, humidity, scan test history, loading rate, time, etc. But filter estimations have always been conjecture. For Camfil, that is not good enough. Camfil has created a new HEPA filter lifetime test grid, the grid, to assist the Megalam EnerGuard development effort and provide the most scientifically advanced HEPA filter analysis in the world. Camfil can control the airflow, particulate contamination concentration, temperature, humidity, scan test and filter challenge simulations, as well as most other variables affecting a filter's service life. The grid monitors all key performance characteristics of the test filters, 9 of which can be simultaneously tested, not for hours or days, but weeks and months, to develop a scientifically derived predictive model which will allow Camfil to finally answer the question, how long will our filters last?
Hello, welcome to Camfil USA in Riverdale, New Jersey. I'm Steve Devine, a member of the Research and Development team. Above me is a system that we've developed to test HEPA filters. Specifically, we're testing the lifetime of HEPA filters and answering the question, how long will my HEPA filter last? Above me is an air intake. We're bringing air in from the room, we're bringing it in from outside, and we're also returning air from below the HEPA filters, mixing them and then filtering it through a MERV 13 filter bank, just the way you would filter your air before it goes through the HEPA filters that you use. To my right is a fan-powered unit. It's a VFD. We're using the VFD to control the volume of air that's going into the plenum above the HEPA filters. Here you see the plenum. This plenum space is quite large and it contains fan-powered units. These fan-powered units supply air individually to 9 different HEPA filters. Here we are standing in front of the lifetime test grid. In this room we have 9 HEPA panel filters attached to 9 fan-powered units. Above me is a plenum. In this plenum, you see we have some hoses and cables. The cable is a network cable. We control the speed of each fan-powered unit using that network cable. We have a pressure tap so we can control the pressure in the plenum and deliver enough air for those fan-powered units. And finally, we have particle sampling. It's important for us to know exactly how many particles are the HEPA filter seeing. Here we are in front of our UDF grid. It really is a UDF grid. We have 9 positions, HEPA filters, unidirectional airflow coming down, and we have a small clean room built here essentially. Inside, I'll bring you in, but we have instruments where we can control all of the functions of the unit, do our data acquisition, and measure how many particles are upstream of those HEPA filters. So come on in, we'll take a look at what's going on. Here we are standing below the lifetime test grid. Above me are 9 HEPA filters with 9 fan-powered units driving them. Below each HEPA filter we have a Velgrid style monitor. We're measuring the air velocity through each HEPA filter. And through our control panel, we've set the air velocity for each filter to be 100 feet per minute. We're also measuring the delta P, the pressure drop across each HEPA filter, and recording all of that data along with all other pertinent data like fan speed, air velocity, air temperature, relative humidity through this control panel. In addition to that, we have a TSI 3340 aerosol spectrometer, and here we're measuring the particle concentration and particle sizes above the HEPA filters. One of the important things to do when trying to predict the life of a HEPA filter is to test the filter periodically, just as the same way that it would be tested in situ. At a customer site, particularly a pharmaceutical installation, it's important to test the filters periodically to be sure they're still working properly. To do that, we use an aerosol generator. Here we're using a TDA4B light. We're able to generate using Alaskan nozzle PAO oil aerosols and inject that from the room side above the HEPA filter. To measure the aerosol concentration above the HEPA filter, we're using this photometer. We have it manifolded together so we can survey, sequentially test each filter that we're applying the aerosol to ensure that we're at the proper set point. We're looking usually for 15 to 20 micrograms per liter. For this segment, what I'll do is demonstrate how we test the HEPA filters. We'll use the aerosol generator and we'll use the photometer to measure the upstream concentration. The first thing we do is we have to remove the grill from the room side of the HEPA filter. The PharmaSeal housing has small attachments so that we can easily drop the grid. This is the aerosol tubing. This will supply the aerosol to the upstream side of the filter housing through an aerosol injection ring. It has a very simple quick disconnect port that we simply plug into to apply the aerosol. We also need to take an upstream concentration measurement. I can easily do that by attaching to the spare port that we're also using for pressure drop. And now I can measure the upstream concentration of the aerosol. Next step is to start the generator and start adjusting valves and pressure so that we achieve 20 micrograms per liter upstream aerosol concentration. Now we're almost at the end of our tour. I'm standing next to the lifetime test grid. On this wall, we have all of our pressure gauges and air velocity measuring gauges that feed the data acquisition system. You can see there's 9 pairs of gauges, one for each fan-powered PharmaSeal. So thank you very much for spending the time to watch this video. I hope you enjoyed what you saw and learned something about how Camfil is learning and measuring and predicting how long a HEPA filter will last. We hope that our models will help you make proper filter choices in the future. If you have any questions, please don't hesitate to contact myself, Stephen Devine, or your local Camfil representative.